reflection probes, bake them, reduce them, and sample smartly. Hello and welcome to episode number 26 of the Unity Performance Task Force podcast. I'm your host Ruben from TheGameDev.Guru, and as usual I kick things off with a question for you. Have you ever added reflection probes to your scene only to realize they're killing your frame rate? Sounds familiar? If so, this episode is for you. When we talk about reflection probes and your project, the first question is, should I need them? Reflection probes are important for achieving realism in rendering. When you render an object, you don't have enough information if you just think about the object itself. You need information about the environment, the number of lights, their angle, their intensity, and ideally global illumination. Reflection probes capture the surroundings of the environment, and at some point you sample this information to get more realism in your 3D scene. Reflection probes are useful for every type of reflection, not just pure mirrors or mirror-like surfaces. You can notice reflections on rough surfaces like stones. Even lacking small hints of reflections can be jarring for users. They can tell something's missing in the scene. If that's the case, it might be because you don't have reflection probes. So, what are reflection probes? Imagine you have a 360-degree camera at one specific point in the scene. You render the scene from that point and take a screenshot or picture for the whole surroundings. If you store this screenshot in a texture, that's all a reflection probe is. It's just a camera that captures the colors of the surroundings at a position. Once the camera captures this information in a texture, every time you render an object, you process this texture to improve the lighting. It helps you get more realism. Now, how does reflection probe rendering work? Technically, a reflection probe is a component in Unity that acts as a camera and stores information about the surroundings. It can operate in several modes, but in general, it's just a camera. Once it captures the environment, you have a texture. When you render objects, you sample that texture in the shader to improve lighting. In Unity, you create a reflection probe component. It has a visual representation like a sphere showing how the texture would be sampled. There are many ways to set this up. I usually like to make them baked. At some point you bake the reflection probe and get a preview. Then when you render each object like a helmet, your shader kicks in and processes the reflection probe information. If you deactivate the reflection probe, there's instantly a difference in lighting. So why are reflection probes expensive? Reflection probes might increase draw calls. Why? When you sample a reflection probe, it depends on the position of both the probe and the geometry you're rendering. If you have 10 reflection probes, one for each room, rendering an object in one room might require a different probe than another room. Changing the probe breaks batching, so you end up with more draw calls. Think of reflection probes as textures. Select a different texture for a different renderer and you might get a different draw call. Reflection probes also increase memory usage. They're just textures that need to be stored, shipped in the APK, and loaded into RAM or VRAM. If you're curious about size, inspect the result yourself. Go to Assets, then your scene location, and you'll see reflection probe assets. You can check the size they take in memory. Reflection probes also increase memory bandwidth. Every time you sample a texture, you transmit bytes between different hardware components, from VRAM to texture cache units. When you execute fragment shaders, you sample texels from the reflection probe texture. That increases memory bandwidth. The bigger problem is real-time reflection probes. If you render reflection probes in real time, especially every frame, it's going to be bad for performance. You practically double your draw calls because you're rendering the scene twice. Even if you render at lower resolution, you incur overhead from context switches between render targets. So how do we optimize reflection probes? Here are 7 key solutions. First, use pre-baked reflection probes. Really. Real-time reflection probes are super expensive. I would never do real-time on mobile. If you're targeting last-gen desktop or consoles, you might get away with it, but check your budget. If you really need real-time, at least don't do it every frame, do it every X frames or render in different sides. Second, reduce reflection probe resolution. One of the problems is increased memory usage and bandwidth. If you reduce resolution, you reduce those problems. You also shade fewer fragments, which lowers GPU shading cost. This is extremely important if you're GPU bound. Third, only use shaders that support and sample reflection probes if you truly need them. Most built-in Unity shaders support reflection probes by default, but if you don't need to sample them for specific objects or scenes, choose a shader that doesn't support reflection probes. The benefit: Unity doesn't bind the reflection probe texture, which decreases draw call cost and memory bandwidth. For example, in URP, the simple lit shader doesn't sample reflection probes, unlike the lit shader. Fourth, restrict the layer mask. The fewer layers you select, the fewer objects you potentially render in the reflection probe. This gives you fewer draw calls and cheaper shading. This is mostly relevant for real-time reflection probes. If you bake, the only difference is more information in the texture, which doesn't affect performance. Fifth, reduce reflection probe count. Every time you add a real-time reflection probe, you increase draw calls tremendously, more than linearly, because you're making lots of context switches. Even if probes are baked, having more increases the chances of selecting a different probe when you move objects, which breaks batching. Place reflection probes strategically. If your player is going through a small corridor, don't put one probe in each corner. Place them where it makes sense at points of interest. For example, if you have a jar on a table, place a probe around that for nice reflections, but don't just put probes everywhere for the sake of it. 6. If you're using runtime reflection probes, treat them as a different camera. Set the clear flag to solid color instead of skybox that adds more draw calls. Be careful with shadow distance and clipping planes. These settings matter a lot for real-time probes. 7th, pay attention to mesh renderer settings. There's a mode selection for reflection probes in mesh renderer settings. Options off, simple, blend probes, and skybox. Off means you only sample from the skybox, great for performance. Simple samples from one reflection probe, probably the closest. Blend probes blends information from nearby probes for smooth transitions. Blend probes and skybox gives the best quality but is expensive in terms of memory bandwidth. So, your action plan. 1. Bake your reflection probes. Do not let them run in real time unless you have a solid reason. 2. Reduce resolution. 3. Sample reflection probe information only when you need it and only in shaders that support it. Use simple lit instead of lit when you don't need reflections. 4. Restrict layer masks for real-time probes to reduce draw calls. 5. Place reflection probes strategically. Don't overdo it. 6. If you're doing real-time probes, tweak settings like clear flag, clipping planes, and shadow distance. 7. Choose the right mesh renderer reflection mode: off, simple, blend probes, or blend probes and skybox. Reflection probes are like cameras that capture environment information. They're useful for every type of reflection, not just perfect mirrors. Bake them, reduce resolution, and sample only when needed. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.